All right, this video is going to talk about what are called half angle formulas. And you'll notice on the screen here, we want to be able to calculate things like over here at the left, the sine of a half theta or cosine of 1/2 theta or tangent of, again, theta over 2/2 theta. Being able to calculate those taking advantage of what we know about theta to begin with. Again, this just gives us an opportunity to find some exact value answers where we may not have known much about the angle or enough about the angle in order to do that. So up top here we have a triangle. Notice it's set up with theta up here in the upper corner here. We got some side lengths. So we can quickly find, again, using just some SOHCAHTOA, the sine of theta and the cosine of theta. And the reason we want these two, and notice I didn't say the tangent, is that there are some shortcut formulas for the half angles. And you'll notice the sine and the cosine look very similar. They're a large square root of either 1 plus the cosine over 2 or 1 minus the cosine over 2, depending on which formula you're looking at. There's also this plus or minus, and I'll come back to that, of why that's in there, or sort of how we use that. The tangent, on the other hand, takes advantage of either 1 minus the cosine over sine, or, notice we don't have to do both. Again, pick one or the other, the sine over 1 plus the cosine. So we do need both the sine and the cosine of theta in order to find the tangent here. So let's take a look. Let's go ahead and find what we know. The sine of theta, again, is going to be opposite, so 24 over hypotenuse, so 26. So let's go ahead and reduce that. Let's make our lives a little bit easier. Let's call that 12 over 13. And again, the cosine of theta, again, could also be reduced, but let's go write it down first. We've got 10 over 26. But again, 5 over 13 is really that value of the ratio, right? We'll take life a little bit easier there. So let's go ahead, we're going to say equal to, and we'll find the large square root of 1 minus the cosine of theta, which for us, again, was 5/13. And then we're going to divide that number, right, that full number, by 2, again, all underneath the root. Make sure your root includes the entire fraction there. So now we just have some simplifying to do. Now you might be asking, okay, what do I do about that plus or minus? The idea behind the plus or minus is, remember that for sines and cosines, we can be positive or negative depending on the quadrant. The nice part for us right now is we're inside of a right triangle, so theta is definitely less than 90 degrees. Theta would definitely be somewhere out in quadrant 1. While half of anything less than 90 degrees is really guaranteed to be less than 45 degrees. So this angle, right, theta over 2, is still guaranteed to be, again, less than, for us in radians, we would say less than pi over 2. In degrees, again, we'd be saying that we're guaranteed, and actually pi over 2, or theta over 2 is less than pi over 4 here, right? We're guaranteed to be less than halfway, which just means the sine is going to be guaranteed to be a positive number. Same thing with the cosine. Anytime we're working up in quadrant 1, again, everything's positive. So we're just going to sort of ignore these plus or minus symbols because we know we're already a positive number. I'll come back to that again in the next example, showing you where that might not be the case. Now it's just some simplifying to do. So again, we've just got some arithmetic. 1 minus 5/13 is technically 8/13. And I'm going to go ahead and take that 2 over 1 on the bottom, and I'm going to multiply by the reciprocal on the top here. So really we have the square root of 8 over 26. And again, it's really just a matter of simplifying now. 8 over 26 is 4/13, but the square root of 4 would have been 2. So we can say 2 over root 13. And if we rationalize, 2 root 13 over 13, and again, we have our number. Let's do the same thing for the next one. Notice this time we're going to add, so 1 plus 5/13 all over 2. But we can essentially follow the same rules. 1 plus 5/13 is 18/13. And then we're going to multiply by 1/2, because again, we were dividing by 2, same thing. So this is now 18 over 26, or 9/13. Well, square root of 9 just happens to be a nice 3 on the top. And therefore, this is 3 root 13 all over 13. All right, doing a little rationalizing there. And then, like I said, for the tangent, we have the option, picking which one we would like. I'm going to go ahead and just go, I don't mind having the fractions on the top. So I'm going to say 1 minus the cosine on the top, divided by the sine, 12/13. and really following kind of the same steps as we did before. We just don't have the big square root to deal with this time. 1 minus is going to be, again, 8/13, multiplied by the reciprocal of the bottom, 13/12, and really cancel the 13s. 8/12 is 2/3. So there we go. And again, you could have also gotten that, remember, sine divided by cosine gives you tangent. So if we actually took the sine divided by the cosine over here, the root 13s would have canceled, and really 2 divided by 3, again, gets us that answer, right? You can get there either way. Let's take a look at another example real quick here of them giving us some different information. Now, one thing we want to remember about finding these, again, is what those formulas are. For the sine and the cosine, excuse me, I only really need to know what the cosine of theta would have been. So if I know the secant of theta is -7/2, well then the cosine of theta is -2/7. Well, and that should be able to get me by, really, for both of these functions. So I can say, again, the square root of 1 minus, well, subtracting a -2/7 is really going to be adding 2/7. So careful with those negatives, and then all over 2 here. So again, 1 plus is going to be the square root of, we're going to have 9/7, and again, multiplied by that, again, 2/1, so 1/2. And we'll have the square root of 9 on the top is just 3, the square root of 14 on the bottom, and a nice 3√14 all over 14 when we're done. Now we do need to worry about that plus or minus again. And in this case, notice that theta, right, if we drew out theta, it's going to be between pi and 3 pi over 2. So it's somewhere down here in quadrant 3, right? Well, that just means that half theta would be like taking all of those parts, right, and dividing by 2, which essentially means that half of theta, right, is going to be a picture. Well, if it's half of pi would have been between pi over 2, right? And half of 3 pi over 2 is 3 pi over 4. We're going to be somewhere in this area, right? We're going to be over in quadrant 2. And I know that sine in quadrant 2 is positive. So again, I'm going to go with a positive answer when I'm done. Let's go ahead and deal with the cosine here. Let's see how that one changes. So I've got 1 plus the cosine. But notice again, the cosine value was a negative, right, 2/7. So 1 minus 2/7 this time over 2 equal to 1 minus 2/7 is 5/7 times, again, that half. And this time we don't get spectacular square roots. Square root of 5 over the square root of 14. So again, we can still multiply root top and bottom. 5 times 14, though, on the top is going to be the square root of 70 all over 14. I don't think that reduces any more than that. Now, before I put a box around it, though, remember we got to go back and think about that plus or minus. Remember that cosine up in quadrant 2 is going to be negative. So in this case, that plus or minus is just going to become minus. And basically our overall answer is a negative root 70 over 14. And then finally, again, we can take advantage, again, of our formulas. We can pick either one of these to work with. Doesn't really matter which one. Or technically, we could just divide these two things by each other. And I think that's the option I'm going to go with, is I'm actually just going to say, so let's actually back up here. We could use that, but I'd much rather just say, well, sine of theta over 2 is divided by cosine of theta over 2, which means we have 3 over root 14 divided by the cosine, or multiplied by its reciprocal. So we're going to get a negative, which makes sense. Again, we're up in quadrant 2. Tangent should be negative in quadrant 2. The root 14 should cancel away, and we'll end up with 3 over root 5, or negative 3 root 5 over 5, right, if we rationalize that denominator. So again, that's using our formulas, and that's how that plus or minus comes into play. Remember that you're looking at where would theta over 2 have fallen Which quadrant is that in? That's going to determine should we have positive answers or negative answers. All right, that's sort of an introduction for you of how to use those half angles. In the next video, I'll have a little example of where we can use that in 2 other places, including solving equations. So make sure you watch the second video, and have a great day.